So yesterday we looked at our different trig identities. We got 5 different sets of them. So our reciprocal identities, quotient identities, our Pythagorean identities, and then the cofunction and even and odd identities. You need to have those first 3 memorized. So the reciprocal, the quotient, and the Pythagorean, you have to have memorized. We use them a lot, and you will need them on the test that we take over chapter 5. So our goal with our identities is to use them for different types of problems. The first way is, last chapter we had problems that looked like this. So use the value secant of u equals -3/2, and tangent of u is greater than 0. Find all of the values of the trig function. And we would make a triangle, use our Pythagorean theorem, and then solve. Agreed? This time we're going to approach it a little bit differently. We want to use those trig identities to help us to find our other trig functions. So if I know that secant of u is -3/2, is there a trig identity that just has secant of u in it and one other trig function? Yes, no, maybe?
Yeah.
Which one?
Secant cosine, or secant theta equals 1 over cosine.
Okay, well I already have secant of theta, right? So I don't need to have secant of theta equal something. I need a different trig function. So is there another one? It's very similar to that one. Yeah, so we know that cosine of u equals 1 over secant of u. Well, do we know what secant of u is? Yeah. So if I plug that in, what do we get? One down. Yay! Okay, so then, same idea. Now that I have cosine, is there one other trig identity that has just cosine and one other function?
1 over CC.
Huh?
1 over secant.
Well, I already have secant, so I need one that I don't have yet. Yes, no, maybe. So what's another trig identity that has cosine in it?
Sine squared theta plus cosine squared theta equals 1.
Agreed. So if we know cosine squared, can we use that to find sine? Yeah. So what is -2/3 squared?
4/9.
Positive 4/9. So then how do I solve for sine?
That 4/9.
Okay, what do we get? 9 9 minus 4 9 gives us 5 9. Is that my answer?
Now you got a square root.
Ooh. Ooh, so we have sine squared of u equals 5/9. So then yes. Now what do we have to add when we take the square root? Plus or minus. How do I decide which one I want to use? Positive or the negative one? What? Not u. That tangent of u has to be bigger than 0. Yeah? So what is going to determine if sine is positive or negative? Where it's at on the graph. What do we mean by that? Yeah, so on our quadrants, which of our functions are positive in my first quadrant? All of them. Okay, which one is positive in my second? Sine. Which one in my third? Tangent, and then cosine. So first of all, it gives us that secant is negative, yes? Which also means that cosine was negative. Agreed? So which one of my quadrants is cosine negative?
2 and 30.
Okay, but then they also gave us that tangent is positive. So which one of those has a positive tangent? Yeah, our third quadrant. So if we're in our third quadrant, what does that tell us about sine?
It's negative.
That it's negative. Okay, so I'm going to choose the negative one. And then what does the square root of 9 give us? 3. So I get negative square roots of 5 over 3. Agreed?
Yeah.
So then once I have sine, what can we find next? Sure. What is tangent going to be? So tangent of u is going to be sine over cosine, which we just found that sine is negative square root of 5 over 3, and cosine is negative 2/3. How do we simplify when we have a fraction within another fraction? Keep it, change it, flip it. So this becomes negative square root of 5 over 3 times negative 3/2, which is what?
3 through 5 over 6.
Yeah, I would probably reduce first.
Square root of 5 over 2.
Yep.
And then 5.
So we should get positive because we have a negative times a negative. My 3 is reduced, so we have square root of 5 over 2.
And that's for tangent?
Correct.
Okay.
So what are our last two that we need to find? Cosecant and cotangent.
Well, you can just flip cosine versus tangent, right?
So we can just flip our tangent to find what?
Cotangent.
Okay, so cotangent of u is going to equal 1 over tangent of u. So we can just flip this and we get 2 over the square root of 5.
Mm-hmm.
Do we want to leave it like that?
No.
So how we're going to write it? 2.
Square root of 5 over 5.
Okay. And then how can we find cosecant? Cosecant is going to be 1 over sine. So we would have negative 3 over the square root of 5. Again, we don't want to leave it like that, so we get negative 3 square roots of 5 over 5. So that's my 5 remaining, right? And they gave us secant to start with, so that's all 6. Agreed? Questions on any of those? So on our test, I would probably give you a question like this, but I would also add using your trig identities. Okay, so that means that you could set up a triangle to check your work, okay, but I'm going to have to see that you're using your trig identities in order to get full credit. Does that make sense? Because this section, we're trying to use our trig identities to find different things, not our right triangle trig, which is what last chapter was about. Are we all with me? So that's kind of the concrete way that we use our trig identities is to find other trig functions, okay? The other way that we can use trig identities is to help us solve or simplify when we have trig expressions. So let's look at an example of that. So what does it mean to simplify something?
Reduce.
Okay, what does it mean to reduce something?
Basically, having a simple form.
Okay, in simplest form. So in this case, what would make that expression simpler? So like right now, how many trig functions do we have? We have 3 trig functions. There's 2 different kinds, right? And then how many operations do we have? We have 2, right? We have multiplication and subtraction. So when it asks us to simplify something, we're usually looking for 2 things. We want less trig functions, if at all possible. And we want less operations. So we're starting out with 2 operations and 3 trig functions. We want to try to get less than that. Okay, that's what it means if we have simplified. Are you with me? Okay, now, one of the things that people tend to not like about this chapter is that these problems do not have a one-size-fits-all steps or formula. There's not a quadratic formula for these types of things. Now, for the most part, we will be using our trig identities, so that's going to be the common theme. But different problems are going to have slightly different steps. So that kind of just involves practicing them. The more you practice them, the better that you get at seeing the different patterns and kind of recognizing which trig identity you want to use. Are we all with me? Alright, so what do we notice first about this one?
There's 2 signs.
There's 2 signs. What else do we notice? Cosine squared. Okay, so anytime that we see a squared, okay, which one of our identities has a squared in it? The Pythagorean. So usually when I see a squared, I'm going to want to use my Pythagorean identity at some point. Okay? So our Pythagorean identity is sine squared of x plus cosine squared of x equals 1. Maybe. Yes? We agree? So like I said, the cosine squared, that tells us that that's probably what we're going to want to use. But right now, do I have a sine squared or a 1 in there? No. So we can't use it right now. But we also pointed out that we have two sines. Agreed? Now, for these problems, y'all tend to freak out or just kind of have a brain lapse whenever we see trig functions. So a nice way to think about them is in terms of just normal variables. So if I had something that was like xy minus x. Again, I have two x's, just like we have two sines. What can we do with our x? Which is also called factoring. Yeah, I can factor out an x. And we would be left with y minus 1. So here we want to do the same thing, except we want to do it with our sine. So if I factor out a sine, I'm moving the sine to the front, and then what are we going to be left with? Agreed. Are we all okay with how I got that? Yes.
I have a question. Why can you not just subtract the sign?
Yeah.
Okay.
Like sign of x.
If
Well,
I had
and then just
something
give
that
you-
looks like this, can I subtract my x's?
Yeah.
I can't because I have to have common terms to be able to subtract them, right? So just like if I have xy minus x, those are not common terms because I have two different things in my first one, right? So on this one, I have a sine and a cosine squared. My second sine doesn't have a cosine squared, so I can't combine them.
Yeah.
Does that make sense?
Yeah, it's just the symbol made it look like this part. Yeah.
Nope.
Made it.
If it was like sine of x plus cosine squared of x minus sine of x, yeah, then you could just subtract them. But because those first two are being multiplied, we can't. So now I have cosine squared of x minus 1. I have a cosine squared and I have a 1. Does that include the things that are in my Pythagorean identity? Yes. Are they in the correct order right now, though? No. So that's the other part, is that sometimes we might have to rearrange some of the things in our identity. So, how would I move my cosine to be over with my 1? Because on my parentheses, I have a cosine and a 1 together.
Subtract cosine squared.
I would subtract cosine squared, because right now we're adding it. So I would have 1 minus cosine squared of x. Agreed? Okay. But what's different about that one than the one I have on the parentheses?
Both those signs are flipped.
Okay, so what could we do to flip our signs?
Multiply both sides by -1.
Agreed. So we get negative sine squared of x equals, so that's going to flip both of our signs. So we would get a positive cosine squared of x minus 1 now instead. Are we all okay with that? Because now, if I have that two things are equal to each other, agreed? Like if I had A equals B, and I had an equation with A's in it, can I substitute B for all of my A's? Yeah, because they're equal, and that's what equals means, yes? So notice that here, I have cosine squared of x minus 1. That's the same thing that I have in my parentheses. So I want to take my left side of my equation, and I'm going to substitute that into that parentheses instead. So we would get sine of x times negative sine squared of x. Yes? So if I have a would have sine to the third, but then what else do we have?
Negative.
A negative. So the negative stays out. So do I have less operations now? Yeah. Do I have less functions now? Yeah. So that's going to be my final answer. We've simplified it to where I don't have as many trig functions or as many operations. So that would be my final answer. Questions on any of the steps that we did?
So you're just solving it like if you get two equations with the same variable, right?
What do you mean by solving it?
Like x plus y equals 1, and then x plus y equals 2, and you just switch it around to equal to x and move the 1 in.
You mean like where I substituted the negative sign squared in? Yes. We're substituting. It's not necessarily solving because we're not solving for x here. I'm just simplifying. Does that make sense? But yes, we can use the equations to kind of rearrange them. That way we can plug other stuff in. Yes. Other questions? Yes? No? Maybe? Alright. Alright, let's look at another one. What do we notice about this one? We have 3 trig functions again, but what's different? Yeah, last time though we had what? We did have a squared. Right now we don't have a squared, which means we can't use our Pythagorean identity as it is. But also, how many signs did we have? 2. So 2 of them were the same. This time they're all 3 different, which means that we are not just going to be able to factor this time. So that's why I said remember that each problem is going to be slightly different. But we have a sine, we have a cosine, and then we have a cotangent. Agreed? So which one of our trig identities has those 3 trig functions in them? Your quotient. And so usually, again, another technique is if I have different trig functions, if I can rewrite them in terms of the other trig functions that we already have, it's going to allow me to simplify. So what could we rewrite cotangent as? Cosine over sine. So again, we're just going to replace what we have for our cotangent with cosine over sine. Now, if it was tangent, it would have been sine over cosine, and our cosines would have reduced, and that would have been nice, because then you would have just had sine plus sine, which is 2 sine. And you might have some that are like that in your homework, where they're a little bit more straightforward, but I want you to see some of the ones that involve a couple more steps and stuff. So what would I do now? Since my cosines don't reduce, what do they do?
They multiply its cosine squared.
Agreed. So if I have a cosine squared, what does that tell me that I'm probably going to do? At some point, it will be the Pythagorean identity. Agreed? Yes? No? Maybe? So what operation is between those right now? Addition, in between my 2 expressions. Yeah. So another thing that we want to look for again is whenever possible we want to try and combine fractions, either by addition or subtraction. So in order to be able to combine fractions, so like let's say if I had 1/3 plus 2. How would I combine those?
You change it to have the same denominator.
Correct, which would be what in this case? 2 over 1, so what does it become?
6/3.
Which gives us? Yeah, so I had to multiply the 2 by what?
3.
Just 3? Then I would have just gotten 6. 3 over 3, right? Because if it just multiplied by 3, then that changes the value and makes it 6. But technically, if I multiply by 3 over 3, well, 6 divided by 3 is still 2. So I didn't change the value, I just changed the way it looked. Does that make sense? So we want to do the same thing here. What is my denominator of my first expression? 1. What's my denominator of my second expression? Sine. So what do I need to multiply my first one by in order to make them the same? Sine over sine. Because again, we're trying to make them the same, but I can't change the actual value. I can only change the way it looks. So it has to be equivalent to 1. So now, what is sine times sine?
Square.
Okay. And then I can add them together. So what's going to be on top?
Sine squared plus cosine squared.
Okay. What's going to be on bottom? Why is it not 2 sine? Because that's not what I do with fractions. So, yeah, just because I have sine on both of my bottoms does not mean that we now get 2 sine in the bottom. Just like here, when I had 1/3 plus 6/3, I got 7/3, not 7/6. Yes, my denominator stays the same. So my sine stays the same. Now, we said that we had a squared earlier. So what did we say that there's probably going to be a good likelihood that we use? The Pythagorean identity. So what is sine squared plus cosine squared using our Pythagorean identity? It's just 1.
Wow.
And then, what is 1 divided by sine of t? Cosecant of t. So that would be my final answer. Did I make it to where I have less trig functions? Did I make it to where I have less operations? Yeah, we made it a whole lot simpler. Agreed? Questions on any of those steps? Again, the hard part of these problems is not necessarily like the individual steps, because none of the individual steps are necessarily hard. It's kind of like figuring out what's my next step, or what do I do next. That's the hard part. And so that's where I said we kind of just have to practice and see different types of problems, because then that kind of shows you different things that you could do next. Does that make sense? Yes? Alright. So let's look at another one. So what does it ask us to do here?
Perform the addition of something.
Perform the addition and then simplify. So what do we have this time?
Fractions.
2 fractions, right? So again, we just talked about how do we add fractions. We have to find the same denominator. But this time, notice that I don't have 1 in either of my denominators. So it would be like if I had 1/2 plus 2/3
You have to multiply by
to which one?
2.
What do I multiply my first fraction by?
3 over
3 over 3. So I get 3/6. What do I multiply my second fraction by? 2 over 2. So I get 4/6. Right? So we get 7/6. So I had to multiply each of my fractions by something. Agreed? In order to make it the same? Are we okay with that? So same thing here. They both have different denominators. So I'm going to have to multiply both fractions by something in order to make them the same. My common denominator is just going to be this denominator times this denominator. Agreed? So what is my first denominator missing? Just a sign. So we're going to multiply by, not sine squared, sine over sine. Because that's the part that it's missing. What's our second fraction missing?
A
1 plus cosine. So that's what I'm going to multiply to the top and the bottom. Do we all see why I chose to multiply by what we multiplied by? Yes? So what do we have in our numerator for our first fraction? Sine times sine gives us sine squared. And then on bottom, we're just going to leave that as sine times 1 plus cosine. And then I'm going to add. Again, there's not really a way to combine those nicely yet, so we're just going to leave them as factors. So then what can we do? Okay, so we get sine squared plus cosine of theta times 1 plus cosine of theta. And then what's going to be on bottom? Just the denominator, rewrite. So, did we perform the addition like it asked us to do? Okay, but what does it ask us to do after that? To simplify. How do we simplify that? Make it smaller, yeah? So can I reduce my sine squared and my sine? And my 1 plus cosine and my 1 plus cosine? No, why not? What? The multiplication part is okay. If I just had cosine of theta times 1 plus cosine of theta on top, I could simplify out or reduce out my 1 plus cosines of theta. Yeah? What's causing the issue? The addition sign there in the middle. So because we have addition, we cannot simplify anything. When's the only time we're allowed to simplify fractions? Multiplication, right? We can simplify factors, and that's multiplication. Are we all okay with that? So what might we do instead to simplify? Well, right now we have cosine times all of this stuff, right? Okay, so what's that called? How do we multiply that? Distribute, okay, so we would have cosine of theta plus cosine squared of theta. Again, I haven't done anything to the bottom, so it stays the same. So now, what do we notice about the top? There's a sine squared and a cosine squared. So I'm going to rearrange that so that those two things are by each other. And we're allowed to do that because it's all addition. And what does sine squared plus cosine squared equal? 1. And that's why I said that's one that we need to memorize because it pops up a lot. So this part right here just equals 1. So again, we can substitute a 1 there. Now we can reduce our 1 plus cosines. So my 1 plus cosines reduce. And we have 1 divided by sine of theta which is also cosecant of theta, and that's our final answer. Questions on any of our steps here? Yes? Alright, we have one last example to look at. Alright, what does the directions tell us to do?
Rewrite it as not a
Rewrite it as not a fraction. Is it a fraction right now?
Yes.
Yeah, so we need to make it not a fraction. How do we do that?
Multiply the bottom by the bottom.
Okay. Can I just divide, like 1 divided by 1 plus 1 divided by sign? Yes, no, maybe. Are we allowed to break it apart like that?
No.
Why not? Because of the plus sign where? On the bottom. Because if I had like 1 plus sign divided by 2, and I just have one thing in the bottom, we could do 1/2 plus sign divided by 2. Yeah? If the plus is in the top, then we could. But because it's in the bottom, we can't. So I agree, we want to multiply by something. What do we want to multiply by?
1 plus sign over 1.
So I can't just multiply the top by something or just the bottom by something. We're going to have to multiply the top and the bottom by the same thing. Otherwise, I can't put an equal sign there.
So multiply by the denominator.
Okay, why are we choosing to multiply by the denominator? Just because?
Yeah.
Okay, what does 1 plus sign look close to? As far as our trig identities go. It has a 1, it has a sign. The Pythagorean identity, right? But my problem is it's not squared right now. Agreed? So if I could reduce that to one thing using my Pythagorean identity, then we could simplify our fraction, right? So yes, we want to multiply by something. If we chose to multiply by 1 plus sign of x divided by 1 plus sign of x. So we would have to FOIL this. So 1 times 1 is what? 1. 1 times sine is what? Sine of x. Sine of x times 1 is what? Sine of x. And then sine of x times sine of x is sine squared of x. What am I going to end up with? 1 plus 2 sine of x plus sine squared? Yeah, it's going to be quadratic, which is not something that we want, because that's not my Pythagorean. What's the problem right now? Is that we have a what?
2 sign.
We have the 2 signs. Is there a way for us to not end up with a 2 sign there? I could just multiply by sine, but then I would have sine plus sine squared, which still doesn't help us to simplify it.
You rewrite sign as
I want to rewrite sine. We're almost there. Very, very close.
The inverse?
What do you mean by the inverse?
Like negative 1 minus sin x and then times it.
Very, very close. You put in too many negatives.
Just minus sin.
Yeah, so we just want to multiply by 1 minus sine of x. Does anybody remember what that's called? When we just flip the sign in the middle. Remember, we've done it with like radicals. So like if I had 1 plus square root of 2 on bottom, I would multiply the top and the bottom by 1 minus square root of 2 to get rid of it.
yeah.
Or if we had imaginary numbers, right? If we had 2 plus I, we would multiply by 2 minus I to to get rid of it, it's our conjugates. So remember, when I flip that middle sign, we do that to get rid of the middle part. Because now, notice, when we multiply,
It just gives us a square.
correct. So 1 times 1 gives us 1. 1 times a negative sign is still negative sign, but now we get a positive sign. So now when we add those together, what are we going to get? 0. So we just have a 1 minus sine of x on top. We have a 1 minus sine squared on bottom. But what does 1 minus sine squared equal?
Oh.
Just equals cosine squared, using our Pythagorean identity. So remember, we said the whole point of trying to rewrite it is because now I have one thing in my bottom. So what can we do? Can we break apart our fractions now? Yeah, as long as I don't have addition in the denominator, we can break apart those fractions now. Because remember, our whole point, or what the instructions told us to do, is to rewrite it so we don't have fractions. So how can I rewrite 1 divided by cosine squared? What's 1 divided by cosine? Secant, and if I have 2 of those, it's going to be secant squared of x. Are we all okay with that? Well, is that a fraction anymore? No, so we're almost there. We're getting closer, okay? Now, I have a sine and a cosine. Which of my other identities has a sine and a cosine? That makes it not a fraction. Not quite cotangent because we want the sine to be on top. Tangent, okay? But tangent is what over what? Sine over cosine, right? But how many cosines do we have on the bottom? 2. So we can't just like leave that out. We do have to have it still in there, okay? But I'm going to break it apart. Are we okay with that? So then what did we say? What is sine divided by cosine? We just said a second ago. Sine divided by cosine gives us tangent. And then we said a second ago, what is 1 divided by cosine? Secant. Do I have any more fractions? Nope. So did I do what the instructions asked us to do? Did I get rid of all of the fractional forms? Do we have any fractions left? No. So did we get rid of all the fractions? Yes. So that is our answer.